This video will demonstrate installation of opencpi on a freshly installed Ubuntu 18.04 virtual machine. Using VirtualBox, the virtual machine has 8 GB of RAM, 160 GB of hard drive space. During the installation process of Ubuntu, the normal installation was selected as well as the checkbox to download updates while installing. After the install was complete, the only thing that occurred was installing the VirtualBox guest editions to allow the screen size to be bigger. The next thing we'll need to do is install Git. So using sudo apt install Git. This will allow us to download opencpi from GitLab. Once we have Git, we can clone the opencpi repository. By default, when you clone, it'll clone the develop branch. So if you need a specific version after the clone is finished, you can check out the version you need to download. Once the repository is cloned, change directory to opencpi. Once in the opencpi directory, execute the scripts install opencpi. The first thing it will do is download all the necessary packages from Ubuntu repositories. After that is complete, it's going to build the opencpi prerequisites. Once the prerequisites are built, it will build the framework itself, followed by the kernel, and then run tests. opencpi tests. Make sure everything is working correctly. The install takes about 40 minutes to complete. So this is your first chance to get a cup of coffee. You'll have plenty of chances to do so. In the interest of time, I'm going to go ahead and speed up through this process so you don't have to sit through it, because you're going to sit through it anyway. But I just wanted to keep it on there so you can see the output, just so you can compare it to yours, just in case something looks funny. After the tests have run, opencpi is installed, but it's only built the RCC platform for the development host itself. So the next thing we need to do is install the vendor tools to allow to build for platforms, in our case, the Z platform, and the RCC platform associated with the Z, because the Z is a Zynq-based platform that has both an ARM processor and FPGA fabric. Next, we'll install the vendor tools. To do that, we'll go and download the web installer for Vitis 2019.2. It's an older version, so you have to go into the Vitis archive, and then the Linux self-extracting web installer. Open that up. You'll have to create an account if you don't have one, but you'll log in, and then you'll click the download button. Once that's downloaded, go back to the terminal. We're going to add executable permissions to that file we just downloaded, the self-extracting installer. Once it's executable, we can execute the script to run the installer itself. Takes a little time to boot up. Okay, just letting you know there's a new version. Hit next. We'll have to log in again using those same credentials. It says user ID, but it's the email now. We're going to use the Webpack version, so you agree to these three end-user license agreement, and then be sure to select Vitis, because that includes the SDK and Vivado. To make sure that download's a little lower, unselect the UltraScale Plus, and the RF SOC options, as well as the Aveo and Xilinx Edge accelerator platforms. We'll click Next. So the default location is tools Xilinx, and that directory doesn't exist, so we'll have to create it. Open up a new terminal. Since it's in the root, create the directory /tools, and then also to change the owner of that directory so that your user can write to it. So it's your user and group, and it's usually just like that. Once that's been created, you go back and then forward, and it will redetect that it's writable. Yep. Once that's all set, you hit the install, and it's your other opportunity to get some more coffee. It's going to take a while, so I'm going to speed through this section, and then once this is done, we'll install the Git repos and the ZynqReleases. Be sure, so in this video, you can go through the different sections. I'm just leaving it here so that you can see the whole entire process of installing opencpi from source. Okay, once the installation completed successfully, click OK. Close that out. Because we're using the Webpack version, you don't need to worry about licenses. So the next thing we'll do is we're going to install the ZynqReleases. So we'll change directory to Tools, Xilinx. We're going to create a new directory called ZynqReleases. So make directory -p. I'm using the full path here, absolute path, just to match up with the installation guide. So we're going to wiki.xilinx.com. On the left sidebar there, the first one is called Linux Pre-Built Images, and we'll select the 2019.2 release. We'll scroll down. So if you're doing this for another platform, those releases are there as well. But right now we're focusing on the Zedboard. It's going to ask you to download it again using your credentials. We'll save as file. So this is going to save it. The default location is the downloads directory. So we need to move that file into the directory we created before. So I'm going to go into the 2019.2, and then I'm going to move in the downloads that archive. And that's all we need to do for ZynqReleases. You'll have multiple ones. Again, if you want to build for different platforms and not just Zed. The next thing we'll get is for the Linux kernel and the U-boot. So we're going to create a directory, tools Xilinx Git, and then we're going to clone the Xilinx Linux repo. It's fairly large, so I'll speed through that as well. Once that's done, we're going to do the same for Xilinx U-boot. So git clone github.com/Xilinx/uboot Xilinx. Great. Now that directory is ready, we can go to our opencpi and we'll source the opencpi environment. Source cdk opencpi-s just set, and then we'll use ocpiadmin install platform Xilinx 19.2 Arc32. So this will cross-compile the RCC platform, opencpi, with the RCC platform that runs on the embedded ARM of the Z. This also takes some time, so we're going to speed through it. Once the RCC platform has completed the installation for Xilinx 19.2 Arc32, the next thing we'll do is we're going to build the HDL platform for the Z. So to do that, you use ocpiadmin install platform Z. We're going to use the minimal flag. And what that does is that instead of building every worker for Z against Z, it's going to do the minimal build of minimal workers needed to build the test bias assembly, which is the bit stream, the default bit stream that gets built for each platform. This will save a lot of time. Otherwise, it can take upwards of 8 hours to build all the HDL workers against the platform. So right here, it's building the test bias bit stream. And that's the installation of the Z HDL platform. So now that we have the RCC platform and the HDL platform available, we can deploy the platform, which that will create the SD card artifacts. We use ocpiadmin and admin deploy platform, Xilinx 19.2, software platform first, and then hardware platform. Once that's completed, we can, in the SDK Z sdcard directory, you'll see the artifacts necessary to boot the Zedboard. So we're going to copy these onto the SD card. So you have an SD card reader. You can mount that on your computer. Let me get that. Okay, got it mounted. We're still in the CDK directory, so we're just going to copy, and then we'll use RL star, and then the location of the SD card. For me, it's media, the username, and then the SD card I'm using is called Z. So it's going to dereference links, that's what the capital L is for, and be recursive. Okay, once that's completed, we can go to the SD card, put the SD card in the Zedboard. I'm going to show you my Zedboard here. So I have Ethernet, I have UART access, and power. I'm going to insert the SD card onto the Zedboard. I'm going to turn it on, and then I'm going to use screen to access the serial port. It by default in Ubuntu it's dev tty acm 0, so screen. You have to use sudo to have read and write permissions for the device, and then the baud rate 115/200. So you'll get some funky characters, but if you hit enter and type in boot, it will boot into the embedded Linux. Alternatively, you can hit the PS reset on the board if it gets into a funky state. You'll notice that just the blue LED is lit. Once the bitstream is loaded, you'll notice a heartbeat LED flashing. So because I'm using a static Ethernet, you can on yours you can have DHCP, but I set mine statically. So I set the IP address uses ifconfig. So this is on the host machine. I'm going to use ocpiremote to load opencpi. So I'm setting the server address to the IP address I set, and I'm loading it with the Xilinx software platform is Xilinx 19.2 and the hardware platform Z. So this will bundle everything into its own sandbox and send it over SSH and run OCPI serve on the embedded platform so that we can execute an application. So now we're going to use ocpiremote start with -b to load a default bitstream, which is that test bias that was built earlier. So you notice it'll come back and let you know that the software and hardware platforms are available for use. And then in the Zedboard, you'll see a blinking LED showing that the bitstream is running. I'm going to run the test bias application. So you notice I'm in opencpi projects assets applications. I'm going to use the -p to force the file read onto the development host, and then run the test bias application, which will read a file and then bias the values, and then write the output to a file, test.out. All right, so you're set up to develop on the Zedboard now.